So the metric system is something that you've been working on since probably about like grade 2, where they start introducing some units of measurements, mostly looking at like, okay, if you're measuring distance, what would you measure it in? Would you be measuring it in grams, or would you be measuring it in meters and things like that? Well, I'm going to assume that you know what these things are measuring at this point, and we're just going to look at converting within the metric system. So it used to be that when we measured things, what unit you were using to measure really depended on where you were in the world. I used to watch World Strongman competitions on TV, and they'd always talk about how many stones the people were lifting. And eventually I did a conversion and got out a calculator and did a conversion and figured out like a stone was like a certain number. I think it was like either 14 kilograms or 14 pounds or something like that. But that's yet another. We got kilograms, we got stones, we got pounds. Think of distance. You've got kilometers, and you've got miles, and you've got furlongs and leagues, and there's so many different units. So wisely, back in the very late 50s, the scientific community got together, the international scientific community got together and said, we need to standardize this, because you're doing science and you're doing science and somebody else doing science in different places of the world, and it's hard to communicate when we're all using different languages. It's even harder to communicate when we're using different numbers. So pretty much everybody agreed that, yeah, let's use this common system, except the United States, where they thought it's going to cost a lot of money for us to convert everything into metric. So we're not going to do it. We're just going to, and because of that, and because we're so bombarded with the United States media here in Canada, and we still are, we're in transition. We're like almost 50-50. I know if I talk to my parents about something, they'll be talking about it in terms of miles and inches. I do that with some things. Like if you ask me how tall I am, I know my height in centimeters because it's on my driver's license. But normally I wouldn't measure myself. If you ask me what my mass is, I know it best in pounds, and then I can convert it into kilograms. If I'm watching a hockey game tonight and they're talking about this big defenseman who's 6'4" and 230 pounds, they're not going to talk about the defenseman who's 1.97 meters and 103 kilograms. So, but in science, even in the United States, science is done in metric. So, and the metric system, to be blunt, is way better than the empirical system. The empirical system that's used mostly in America, and there are other countries as well that kind of have a little bit of both. I think in Britain it was kind of 6 of one, half a dozen of the other, pretty close to 50-50. It depends on where you were. I found when I was there, if I was in a more modern place, it would be a lot of metric, and if I was in a little bit more out of the way place, and we were in northern Scotland, it tended to be more empirical. So, I mean, some of the units that are used, there's a little Wikipedia page. Some of the units that get used, a foot. And here's one that most people know. A foot is 12 inches. Okay, sure, why not? A yard is 3 feet. And then a chain and a furlong and a mile and a league and a cable. So, all these different numbers. So if I'm given something in leagues and trying to figure out how many yards that is, okay, I'm going to go from leagues to miles and miles to furlongs and furlongs to chains to yards, and having to know different numbers for each one of those things. And that's just for distances, right? That's just a unit of distance. If I want to do different units, areas, perches, a rood, never even heard of a rood. Acres we probably have. There you go. Grams. All right, that's metric. An ounce, a pound, a stone. Yeah, there we go. 14 pounds. So now different numbers all over the place. Different numbers. So it's really difficult. You'd have to memorize a whole bunch of stuff, a whole bunch of numbers in order to do those conversions. In the metric system, you have to memorize, you have to know what number. 10. Always tens. Now, we're going to talk about the prefixes later on, and you should know what those prefixes mean, but the prefixes are the same for every thing that you can measure. Like a millisecond has the same relation to a second as a millimeter does to a meter, or a millitesla does to a Tesla. You don't even have to know what the units mean in order to convert between them. So your common or base units, meter, notice it's RE and not ER, speaking of the United States. You spell it ER in the United States, you do not spell it ER in Canada. Meter, liter. METER is a device used to measure, like a thermometer, thermometer. That's ER. But RE is a unit of distance. Grams, seconds, whatnot. So the prefixes denote multiples, actually it's multiples of 10 of these units. So you're always multiplying by 10, or dividing by 10. So because it's always 10, and multiplying, dividing by 10 is just a matter of moving the decimal, that's all we need to do here. Moving the decimal to convert between units. You can't do that in empirical units. I can't take 100 inches and move the decimal and say that's 10 feet. It's not. Same thing, ounces to pound is so much. So just as we talked about yesterday, any quantity then is written as a number and usually a unit. That unit needs a base that tells you what you're measuring, and a prefix that tells you how much of it you're measuring. So in the example 53 milliliters, your number, your base is a liter, and your prefix is milli, and it tells you milli means 1,000. So 53 1,000ths of a liter. And it doesn't matter, I could put a unit in here that you've never heard of before. Like a Tesla. What's a Tesla measure? Anyone know? It measures magnetic fields. But you didn't need to know that in order to figure out how many Teslas 53 milliteslas is. Because the milli is what's important there. The bases have to match, but you don't have to know what the base actually represents. I mean, you would if you were doing problems with that particular number. But in terms of actual conversions, not so much. So there's a couple of different ways of going about converting between these units. I would expect you to be able to do, by the time you get into, say, a grade 11 university level class, you should be able to do it about as easily as writing your own name. So we have our base unit right over here. Make it a big line, you can put an X there if you want. And then we move off with different prefixes. So there's actually a unit in there, the deci. There's not a lot of stuff we talk about in decis, with the exception of probably the decibel, decibel. A bell is a unit of volume of loudness of sound. Centi we tend to use quite a bit, and milli we use a lot. So after this, every third power of 10 has its own prefix. So 1, 2, 3, 1, 2, 3. Kilo, we have deca and hecta over here. A hectare, for example, is 100 meters by 100 meters. We don't tend to use that a lot, so we'll go straight to kilo, and then 1, 2, 3 mega, 1, 2, 3 giga. Is that it? Are these all the prefixes? No, there are more. You go down to 10 to the minus 18 here. I think you've got pico and fenti and atto, I believe they are. And on the other side, everyone probably knows what the next one is over here, tera, terabyte computer. And then after that, I'm not sure what they are, but they go to 10 to the 18 as well. So once you know this, I think this is a reasonable amount of prefixes, and I would expect you to know these ones. Right? I'm not a huge fan of memorization, but I don't want you constantly having to look up what micro means every time you have to do a unit conversion. So you should be able to know how to do that. For me, the easiest way to do this, you can do it using scientific notation and just adding and subtracting these numbers from your original number as well. I tend to just think of it as moving decimal places, which does have some limitations. How many powers of 10 are you moving from one digit to the other? And then slide the decimal that many powers of 10. So as an example, so let's say we've got 385,000 millimeters, and I want to figure out how many kilometers that is. I won't say that they're really common things. I can't imagine there have been very many times in my life where I've had to, in my real life outside of school, where I've had to do conversion from millimeters to kilometers. But you should be able to know how to do it. I've definitely done meters to kilometers many, many times, and a variety of other conversions that I've done many times. So you go back up to this little chart if you need to, and you say, all right, I'm starting with millimeters. So I go 1, 2, 3 to get back to the base, and another 1, 2, 3 to get over to kilo. So you just look at the prefixes, milli to kilo. So I'm moving 6 places in total. So I have to move my decimal 6 places. Now you gotta make sure that you're moving it in the right direction. And should be an easy one. When your unit gets bigger, your number has to get smaller. Yeah, again, the balancing that we talked about earlier. Unit gets bigger, number gets smaller. You want the number to get smaller, you gotta move your decimal to the left. So I gotta move it 6 times to the left. 1, 2, 3, 4, 5, 6. Right there. So I mentioned this yesterday, never start a number with a decimal. So you gotta put your 0 in front there. So 0.385. All of those other zeros are just there to hold in place, and you chop them off. And that's not a comma, that's a decimal. 0.385 kilometers. Okay, simple as that. If we're going the other way, and I have, let's say 385,000 millimeters, and I want to figure out how many micrometers that is. Milli to micro, you go back up to your chart if you need to. Maybe you remember them. Maybe you go milli, micro is the next one, so these 3 digits away. So now I'm starting with my 0 over here, and I go 1, 2, 3. And I got to fill in those little gaps. So that gives me 385 million micrometers. If you prefer to look at this in a power of 10, in a scientific notation, 3.85 times 10 to the 5, and I had to move the decimal place 6 times. What I'm really doing, I'm subtracting 6. from the power of 10. So I'm going to subtract 6, and that's going to give me 3.85 times 10 to the negative 1. You still need to know how many powers of 10 you're going over, right? That's the key to this whole thing. How many decimal places essentially are there between milli and kilo? Now, where this gets a little bit more complex is when you're dealing with things like area or volume. So when you're dealing with area or volume, you kind of have to do the calculation multiple times. So think of a situation like this. I have 1 meter by 1 meter. That's going to give me an area of 1 meter squared. So now I want to figure out how many centimeters squared that is. So you might think, oh, when you go from meters to centimeters, you're moving the decimal place twice. So you could say, oh, well, okay, 1, move the decimal place twice, it's going to give me 100. So it's 100 centimeters squared, right? Not so much. Because you have to do the conversion twice. How many centimeters is 1 meter? 100 centimeters. But that also means that this meter on the bottom is also 100 centimeters. Now when I calculate the area of 100 times 100, it's going to give me 10,000 centimeters. Now, it's not always going to be easy to look at it this way because you don't necessarily know what the dimensions are. So let's say I have 638,000 millimeters squared, and I want to figure out how many centimeters squared that is. So, because we have to do the conversion once for one side and once for the other side because it's squared, that's what we're going to do. To go from millimeters to centimeters, what do I do? How many places do I move the decimal? Just one. Okay? So I'm going to move the decimal one place. My unit's getting bigger, so my number has to get smaller. I'm going to move the decimal one place. But that just gives me one side. I want to do, since it's millimeters squared to centimeters squared, I have to do it again. So I move my decimal 2 spots over here, and it's going to give me 6,380 centimeters squared. If it was cubed, how would this change? If I was going from millimeters cubed to centimeters cubed, I was going from millimeters cubed, same question, 638,000 millimeters cubed is how many centimeters cubed? It's still one decimal place to go from millimeters to centi, from milli to centi, it's one decimal.
638.
Yeah, so you're going to do it 3 times. You're going to go 1 for one dimension, 1 for the second dimension, and 1 for the third dimension. Right? And that'll give you 638 centimeters cubed. Last thing is time. Time's a little bit different. Time can still use the metric system, like you can still have milliseconds, but we tend not to talk about kiloseconds. Right? Like you don't say, oh, I ran a race on the weekend and it took me 15 kiloseconds. Right? What unit would you probably use rather than kiloseconds? Minutes, maybe hours if you got up to that. So really what you need to know is how many, your second is kind of the small unit. Anything less than that, you'll be using metric. You need to know how many minutes there are in a second and how many hours there are in a minute and how many minutes there are in an hour, hours there are in a day, days there are in a week or a year, for example. And so, seconds in a minute? 60 minutes in an hour, 60 hours in a day, 24 days in a year. Ooh. well, about 365. It's actually 365.26. But it just happens to work out that way. And because it's about an extra quarter of a day every year, we just wrap up those quarter of a days and we get an extra day every 4 years. And that's why we have leap years, roughly. So if you're going from seconds to minutes, are you going to multiply or are you going to divide? Same concept. The unit gets bigger, the number gets smaller. So we're going to divide all the way here, divide, divide, divide. If you're going to go the other way, then you're going to multiply, multiply, multiply. Most people kind of do this naturally anyway, but it's a little bit different. These are still considered metric units, even though they're not powers of 10. It's the one exception. All right.